Hello everyone, welcome to today's class. This is Teacher Simon taking you through Cambridge International AS and A-Level Mathematics Paper 5-2 for October-November 2024, and this is part 2 for questions 5 to 7. Question 5 is coming from combinations. Okay, in a class of 21 students, there are 10 violinists, 6 guitarists, and 5 pianists. A group of 7 is to be chosen from these 21 students. The group will consist of 4 violinists, 2 guitarists, and 1 pianist. Okay, then part A. In how many ways can the group of 7 be chosen? A group of 7 to be chosen. So we have already 4 here. So out of the 10 violinists, we shall need only 4. So 10 combination 4. And then out of the 6 guitarists, we only need 2. That will be now 6 combination 2. And then the other one is going to be 5 combination 1. So what do we get? 10 combination 4. Let me first write each of them. Then 6 combination 2. That will be 6 times 5, 30 divided by 2, that has to be 15. And then 5 combination 1 is a 5. So altogether, what do we get? 210 times 15 times 5. That is 15750. 15750. That's the answer there. Then they are saying on another occasion, a group of 5 will be chosen from the 21 students. The group must contain at least 2 violinists, at least 1 guitarist, and at most 1 pianist. Okay, now we should know the meaning of these words. If we say at least, this one means greater or equal. Okay, then at most, this one means less than or equal. Okay, now these are going to be our scenarios. So let's look into what is here. I can have the 10 violinists. Then we have 6 guitarists. And we also have 5 pianists. Okay, now since they said at least 2 violinists, let me begin from there. 2, then maybe 2 here, because they also said at least 1 guitarist. So the least you can have for the guitarist has to be a 1. So 2, 2, then 1. I can have 2, I can have 3, I can have 0. I can have 3 here, and then I can have 2 here, then 0 here. Okay, I can have 4 here, then 1 guitarist, and then 0 here. Remember, my totals have to give me 5. Then I can have 3, then 1, and 1. Okay, and I think those are the only ones that we can have. Okay, now this one will be 10 combination 2 times 6 combination 2 times 5 combination 1. Okay, I'm putting all of this together. Then out of the 10, we are having 2, so 10 combination 2 times 6 combination 3 times 5 combination 0. And the next one, 10 combination 3 times 6 combination 2 times 5 combination 0. And then we have 10 combination 4 times 6 combination 1 times 5 combination 0. Then we shall have here 10 combination 3 times 6 combination 1, then times 5 combination 1. Okay, then I can put this in the calculator, and then I get my answers. Okay, and then after that, I get the total. So what do I get here? Here, 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 and here. 10 combination 2, then times 6 combination 2, then times 5. That is 3375. 3375. Okay. In fact, let me take this one down here. Then what else do we have? We have 10 combination 2 times 6 combination 3. Of course, 5 combination 0 is a 1. So that is 900. So come on right here, 900. And then the next one will be 10 combination 3, 6 combination 2, 5 combination 0 is 1. So 1800. 1800. Then the next one, which is 10 combination 4, then times 6 combination 1, and that one will give us 1260. 1260. Then lastly, we shall have 10 combination 3, then 6 combination 1, then times 5 combination 1. There's a 5 there. So we get 3600. 3600. And then the total here, we just add each and everything here. Okay, so let's add and see. 3375 plus 900 plus 1800 plus 1260 plus 3600. That one gives us 10, then 935. 10,935. So that is that. Question 6 is coming from statistics and particularly stem and leaf diagram. Teams of 15 runners took part in a charity run last Saturday. The times taken in minutes to complete the course by the runners from the Falcons and the runners from the Kites are shown in the table. And the results here are actually given in ascending order. So that one is very good. So in arrangement, it will help us because it is already arranged. Now, the assigned part A, draw a back-to-back stem and leaf diagram to represent this information with falcons on the left side. Falcons on the left side. Very important. If you put it on the right, then you are gone. Now, a stem and leaf diagram, we have a stem here. The numbers in the stem must be increasing downwards, and we must have one value, okay? One value on the stems. If let's say we had 3 digits, 2 digits would go here, and then the digit in the one's place, or the last one, is the one that will go this side, okay? Then after that, the numbers that we put on the stem must be aligning vertically, must be in a line, okay? You don't write a number here, a number here, then the other one down, you will write it in between here like that. No, they have to be aligning vertically. And then lastly, there has to be a key that represents your data. If you say 0, maybe let's say 5, then 2, then what does it represent? Like what is here? You have a number here, you have a number this way and this way. What does it represent? Then you can tell us that. So that is what we call a stem and leaf diagram. Okay, so now let me draw the neat table here. Okay, so after that, I can put falcons on the left, and then I put kites on the right. Now we can see 30s, so I can write 3, I can see 40s, I can see 50s, there are 60s, and then 70s. So those are the ones that we have. Let us begin with the kites. So the list is 32. So write 2 here, 40s are here. You write them in that order. So 40, there is 40, there is 45, then there is 47, and then 48. Then let's go to the 50s. They are all here. So we have 52, we have 54, we have 58, we have 2 59s. Okay, I think you can see that I'm aligning my numbers vertically. Then the next one, 60s, we are having all of these. So those ones are 4. We shall have 0, 1, 3, 5. Now you realize that there is no 70. Don't put a 0 here. This one will represent a 70. Okay, so just leave it blank, just like that. Now let's go to the falcons. So we have, these are 2. So there is 8, then there is 9. They have to be increasing this way. And then we have the 40s, 42, 44, 46, 48. Those ones there. There are 4 of them. So we shall write a 2, then a 4, then 6, and then 8. Okay. Then from there, we can go to the 50s. The 50s are all here. Many. 50, 51, 52, 56, 58, 59. Okay. So there is 50, 51, 52, 56. Then there is 58, and then 59. Then next, we go to the 60s. They are just 2, 64, and 69. So we write a 4, and then a 9 here. Okay, and then lastly, there is 76. So we shall put a 6 here. And then after that, we are going to write a key that represents our data. Okay, so I'll write the key here. The key has a full mark. If you don't put it, you lose it. I can have maybe 0 stroke 5 stroke 2. Just pick something here. You can pick this one. You can pick this one. Or a number this way and a number this way, wherever, like that. So we are going to have 052. This one means 50. So I move from the stem, then I go this side. That is 50. Okay. So this will be 50 minutes for the falcons. Okay. And I have now 52. Now on the right, we have the kites, and 52 minutes for the kites. As simple as that. But we find the median and the interquartile range of the times for the falcons. Okay, for the times for the falcons. Now, when we check these values, we are given, how many values do we have here? They told us already 15 members. So if there are 15, when it comes to the median, I'm going to cross, and then I remain with one number in the middle. Okay. So since we are looking for the ones of falcons, now you can see I can even just cross from here. This with this, this with this one here, this with this with this one with this one, this one with this one, this one with this one. So we remain with 51 in the middle. But now this 51 is in which position? So this is 1, 2, 3, 4, 5, 6, 7, 8. Okay, it is in the 8th position. Since we are having 15, then we can say 15 plus 1 over 2. Because 15 plus 1, that one will give you the 16, right? Now 16 divide by 2, you get the 8th. You see that? Now, that means I'll come here and write, because you can be given very many values. You are not going to arrange them and then you begin crossing. So median is going to be that 15 plus 1. If the number of figures given is odd, you first add a 1, okay? Then after you divide by 2 if you're getting median. Then for quartiles, you also do the same. So this will be the 8th value. And of course, we have seen that that is 51. So I write 51 minutes. Okay? Then upper quartile, because we need the interquartile range. What is the upper quartile? Upper quartile is Q3, which is equal to 3 quarters. A quarter is a number that divides the given distribution into 4 equal parts. So a quarter of 16, this is 4. Now times 3, this will be the 12th value. Okay, the 12th value. And then the lower quartile. Q1 is going to be a quarter of that 15 plus 1, which is actually the 4th value. So let's go and check the 4th and 12th. The 4th value, 1, 2, 3, is 44, the 12th value. 5, 6, 7, 8, 9, 10, 11, 12. This is the one. So we have 59 and 44. 59 and 44. So this is 59 and then 44. So the interquartile range, the IQR, which is the difference between the upper quartile and the lower quartile, we shall have 59 minus the 44, sorry, minus the 44. This one will give us 15 minutes. As simple as that. Here they are saying let X and Y denote the times in minutes of a runner from the Falcons and a runner from the Kites, respectively. It is given that summation of X is equal to 792. That means they get their times, they add them all together, okay? And then EX squared, when they get their times and they square them, then after they add, this is what they get. Then summation of Y is this, and then summation of Y squared is that. And then you're saying find the mean and standard deviation of the times taken by all 30 runners from the two teams. Now, to get mean, okay, to get mean, I'm supposed to add up the values, then I divide by how many they are. But since I have two groups and I have the sum for one group, I also have the sum for another group. I put together the two sums, okay? So I'll get the summation of X. I add the summation of Y. Then, since I've put the two groups together, then the number of the people, the total number of the people, I will get the number of those who are coming from the Falcons and also the number that is coming from the Kites, and then I put them all together. So I'll have N1 plus N2. Maybe N1 is for the number of those people in the Falcons, and then N2 for the Kites. A mistake which is done here is this one. People get the mean of the X. They get this one here, 792, divide by Falcons. Then they say they also get the mean of this one, which is 783 over the N2. Then after they divide by 2, they get the average. That is very wrong. For mean, we get those totals, then we divide by how many they are. So our answer is therefore going to be summation of X is 792, then plus summation of Y is 783, then divide by, of course, there are 15 members, okay? That all will give us the 30. So 792 plus 783, okay? What do we get? Then we divide by 30. 792 plus 783, then divide by 30. That one is 52.5. 52.5. Okay. Similarly, the standard deviation is going to be equal to the square root of the variance. So usually we have summation of X squared. We have something like this, summation of X squared over N, then minus the summation of X over N, then squared. And this one is actually given in the list of family, okay? But since I'm having two groups, then I'm going to consider both of them, okay? So summation of the squares, that is summation of X squared, then plus the summation of Y squared, then divide by N1 plus N2, then subtract summation of X plus summation of Y over N1 plus N2, and then squared, okay? The mean we have gotten. Now, we are going to have the summation, the square root of, for X squared, it is given as 43504. Then for Y squared, it is given as 42223. And then we shall divide by, of course, it is 15 plus 15. And then minus this one that we have done before. I can write 52.5 because it is already it is a terminating decimal. Okay, but if it is not a terminating decimal, you can put this whole thing here. So I will just put 52.5 here squared. So putting all of this in the calculator, what do we get? Square root of 43504 plus 42223. Then we are dividing by 30. Then subtract, we have 52.5 squared. So altogether we get 10.1 to 3 significant figures. 10.1 to 3 significant figures. So that is that. Question 7. In a game, players attempt to score a goal by kicking a ball into the net. The probability that Leno scores a goal is 0.4 on any attempt, independently of all other attempts. That means it can either be a geometric or a binomial. So the random variable x denotes the number of attempts that it takes Leno to score a goal. Okay, then as in part A, find probability of x is equal to 5. Now here the number of times the experiment is done isn't known. Okay, it doesn't mean that it is infinite. Okay, but it is not known. So that means this is a geometric distribution. This is a geometric distribution, since n isn't known or fixed. Okay, so that is that. And our p is given as 0.4, therefore q has to be equal to 0.6. And probability of x is equal to r for the geometric is q r minus 1 then times p power 1. What does this one mean? That if this person gets a success on the 5th one, that means has been failing in the first 4 times. So failed on the first one, second one, third one, fourth one, like that. So that means we are getting q power 4 then times the p power 1. Okay, so q is 0.4 then power 4 times the p, which is 0.4. So when we multiply this, what do we get? 0.6 power 4 then times 0.4. That is 0.05184. 0.05184. This one I will leave it like that because it is a terminating decimal. It is not a rounded figure, such that we write to 3 significant figures. Then this one, probability of 3 less than or equal to x less than or equal to 7. This one is going to be equal to probability of x is equal to 3. Then probability of x is equal to 4. Then we have probability of x is equal to 5. Then we have probability of x is equal to 6. And then probability of x is equal to 7. So we shall have here q power 2, just like here. Okay, we're substituting in this. So 3 minus 1, that is a 2. So q power 2, that will be 0.6 power 2, then times the 0.4. Then plus 0.6 power 3, then times the 0.4. Then we shall have 0.6 power 4, then times the 0.4. Then 0.6 power 5, then times the 0.4. And then 0.6 power 6, okay, times the 0.4. And then we can put all of that in the calculator. However, I can put 0.4, which is common everywhere. Then 0.6 squared, 0.6 cubed, 0.6 power 4, 0.6 power 5, and then 0.6 power 6. So what do we get? 0.4 into 0.6 squared plus 0.6 power 3 then plus 0.6 power 4, then plus 0.6 power 5, then plus 0.6 power 6, and then we can close the brackets. So that is 0.332 to 3 significant figures. 0.332, just like that. Alternatively, you can do it this way. Alternatively, we can say probability of 3 less than or equal to x less than or equal to 7 is the same as probability of x less than or equal to 7, then minus probability of x less than 3. Why am I choosing less than 3? The numbers 3 and 7 are inclusive. 7 and 3, they are inclusive. So we want from here to there. That means I will get from here less than, from here the whole of it, then we subtract before this 3 because 3 is inclusive. Okay, so that's what we are having here. Now I can draw my tree diagram for a normal distribution. Okay, I mean for the geometric distribution. Let me just draw it here. I can have a success, then if I fail, I continue. Success, you fail, you continue. Q, like that. P, Q, then like that. I'm going to go up to 7. Okay, Q. This is 1, 2, 3, 4, 5, 6, and then 7 here. Okay, I'm going to take this as my tree diagram there. Now on that tree diagram, if we say less than or equal to 7, that means you're going to consider 1 success, 2, 3, 4, 5, 6, 7. So we are considering all of this: P, Q squared P, Q power 3P, Q power 4P, Q power 5P, Q power 6P. Okay, but you realize that it is only this one that is left out. Okay, that means I will just say 1, then minus this Q power 7, as simple as that. Okay, 1 minus Q power 7. So I'll write here 1 minus Q power 7. Okay, then I will subtract now less than 3. If it is less than 3, that means we have 1 and 2. So I will have P, then also QP. Okay, less than 3, so we don't reach here. So it is, we only cut it from here. Now, if we have P and then QP, do you realize that it is this one that is left out? So I will say 1 minus Q squared P. Okay, 1 minus Q, not Q squared P, 1 minus Q squared, just like that. Okay, now when I do that, when you try to open the brackets here, you will get 1 disappearing because it will be 1 minus 1, it goes. Now this Q squared here, it's negative, it will become a positive with this one. So it will be Q squared, okay, Q squared, then minus Q power 7. Do we get the same answer? Let's check. Q power 2, our Q is 0.6. So squared, then minus 0.6 power 7. Do you see that we get the same answer? 0.332. Okay, so that is that. You could also do it that way, 0.332. Find the probability that Leno scores his second goal on or before his 5th attempt. Okay, now the second goal, if the second goal is scored on or before, all means addition, okay, or before. So let us look at something here. Suppose it is scored on the second attempt, okay, on the second attempt. So meaning here it is, the goal is scored on the first attempt, okay, then scored on the second attempt. This is 1, 2, 3, 4. There's a 5. Then let me also consider the third attempt. There must be a wrong spelling here. attempt. Okay, so even here attempt. How about fourth attempt? And then fifth attempt. Okay, and then fifth attempt. Now we have 1 2 3 4 5 1 2 3 4 5 1 2 3 4 5. So scored here, scored here, scored here. In fact, let me remove these ones because this is a geometric. When they score the second goal in the attempt, it is done. The goal is scored on the second attempt here. Okay, then third, fourth, and then that. Now we are going to have on the first attempt here, that means the goal is scored. Okay, so let me use the combinations here. Here there are 2 attempts, but only one is for the goal. Okay, that is where he scores the goal. And then here there are 3 attempts. There is 1 goal, and then the rest are failures. Then in the 4 attempts here, there is 1 which is a success, and then the 3 are gone. Remember, the goal can come on the first attempt here or on the second attempt. Here it can be on the first, on the second, or on the third. So that means there we're multiplying by 3. Then here it can be here, 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 or here. So we are multiplying there by 4. So in other words, I will take these as binomials. Okay, and I say out of the 2 attempts, 1 gives us a success, and the success is 0.4. Okay, and then 0.6 here, or 1. But then I will multiply with the 0.4, the last success here. Okay, then also here, out of the 3 attempts, 1 is for the success, 0.4 power 1, then 0.6 here, power 2, and then we shall have 0.4 last here. Then out of the 4 attempts, 1 is the success, so 0.4, then power 1, and then 0.6, then power 3 here, and then times the 0.4. Okay, of course the first one here, you have done 1 attempt, so 1 combination 1, that is your success here. In fact, I'm not going to waste my time here. I will just write this is 0.4, the success, but then times the other 0.4 at the end. Okay, and then I multiply all of these, and then I add all of them. So this is probability is going to be, I'm going to put everything, okay, together. So 0.4 times 0.4, that one gives us 0.16. So 0.16, then plus 2 combination 1 is of course 2, then times 0.4 times 0.6, then times 0.4, the last one. That one gives us 0.192, 0.192. And then the third one is 3, combination 1, which is 3 times 0.4 times 0.6 squared, and then times the 0.4. That one will give us 0.1728, 0.1728. And then lastly, 4 times 0.4 times 0.6 cubed, and then times 0.4. So this one will give us 0.1384. Then when we add all of these, what we get? 0.16 plus 0.192 plus 0.1728 plus 0.13824. So we get the answer as 0.66304. 0.66304. Can even leave it as that, or to 3 significant figures. Okay. Next, Leno has 75 attempts to score a goal, but they use a suitable approximation to find the probability that Leno scores more than 28 goals but fewer than 35 goals. Of course, this is binomial approximation to the normal. And for the normal distribution, we need to get the mean, but the mean we are going to get is the one that is coming from the binomial. Okay, so the binomial, this is the binomial distribution because n is known. Okay, and the scores are independent of each other. So mu is going to be NP here. So our N is 75, and then the P is 0.4. We have seen it before. So this one gives us a 30. And then the standard deviation, which is the root of variance, and variance is given by NPQ. Then we shall have the square root of 75 times 0.4, then times 0.6. What does this one give us without the square root? 75 times 0.4 times 0.6. That one gives us 18. So we shall have square root of 18. Now, before approximating a binomial to the normal, we carry out continuity corrections because we are moving from discrete data to now continuous data. Normal distribution deals with continuous data. Now, I can have in our continuity corrections, in the previous videos, I've always shown you how it comes about. So this is 28, but here there is 27. Okay, then there is 29 here. Now I'm going to skip and also come this side, and I put 35, and there is here 34, and there is also 36. So in carrying out continuity corrections, we use the bounds of these numbers. Okay, 28 starts to be so at 27.5 and then ends at 28.5. So this is the region of the 28, and then this 35 is 34.5. That is where it starts from, and then it ends here at 35.5, because when you round off 35.5, you don't get 35, it goes off. Okay, it goes to 36. So that's why when we are writing these numbers like the 28, we say less than or equal to that 27.5, because whatever is here, when it is rounded off, it gives you the 28. But then here we put less than 28.5, because all the numbers here, when you round them off, they give you the 28. But when you include 28.5, it will now give you 29. It is no longer 28. So that's why we use the less than there. Okay. So that is that. Now, when I'm finding the probability of 28 less than x less than 35, this one is the same as we want below 35. Okay, below 35 and also above 28. So that means 28 is not included. So I will say I will get the whole of this less than the 35, then I will subtract less than or equal to 28, because 28 is not inclusive in this picture. You get it? So this one is going to be, I'm going to write probability of x less than 35, then I'll subtract probability of x, which is less than or equal to 28. Now from here, I can standardize. Now, when it is less than, when we round off these numbers, what we get must be less than 35. So you go to 35. It has to be less than this 34.5. Okay? Because whichever numbers that are below this 34.5, it will be, when you round them off to the nearest whole number, it will be less than that 35. But remember, we are using these bounds, either 35.5 or 34.5. Okay? So, and I've always said that if it is less than, you always subtract a 0.5. So for less than, subtract a 0.5. For less than or equal, add a 0.5. And then for greater than, add a 0.5. And then for greater than or equal, you subtract a 0.5. Okay, I've already said this in all the previous videos. So this one, we shall have probability of z less than, subtract a 0.5 here, it will be 34.5. Remember, z is equal to x minus mean over the standard deviation. So minus our mean, we have gotten as 30, then divide by root of 18, and then we subtract here. It is z less than. In normal distribution, we don't have less than or equal or what. So if the sign is given as less than or equal, then it changes to the less than. Okay, then we have said here for the less than, we are adding 0.5. What do we mean by adding a 0.5 when it is less than or equal? Okay, That means when we round off all of those numbers, okay, what we get has to be 28. So when you look at this one here, the numbers which are below this 28.5, whatever you get will be that 28. Okay, will be 28 and less than. So it is the whole of this one here. So this is the highest, less than 28.5. Less than 28.5. So that's why we are adding a 0.5, okay, to get this one here for the less than or equal. But the easier way to understand this, you just get for less than, it is minus 0.5, okay? Then for greater than, it is plus 0.5. Are we there? Then there or equals, you reverse the sign, okay? You reverse the sign, as simple as that. You won't get any difficulties in continuity corrections. So without wasting time, this one will be probability of z, then less than, I'll get 28.5, then minus the 30, divided by the square root of 18. Okay. And then, of course, I can first simplify this one. Probability of z less than 34.5 minus 30. That one gives us 4.5. If you want to use a table, because all of these ones are less than, you can write this to 3 decimal places. Then you go and read from the table. Okay. So minus, then probability of z here less than negative 1.5 over root of 18. But I have always shown you in the previous videos how you can get this from the calculator. Now, if you have your calculator as FX991ES, you can come to your mode here. You press mode, then you go to start, that is 3, and then this one comes on the screen. Then you press SC. Now start comes onto your screen, then you press shift, then 1. That is where we are having statistics 1. Then distribution is 5. Okay, P is for the less than, R is for greater than. Okay, and since in the normal distribution table we use less than, so I will end there. But option 2 is from the middle 0 to the Z value. Okay, now let's take the P, which is for less than 1. Then I'll just put 4.5, then divide by the square root of 18, like that. So it gives me 0.8, 555, and then 8. So I'll come here and I write 0.85558. When you are reading from the table, you read only 4 decimal places. The calculator I have here gives me up to 5. How about when I put negative 1.5 over root of 18? So I'll just come to this and I change to negative 1.5. Okay, and then press equals. That is 36184. 0.36184. When I subtract these two, what do we get? 0.85558 minus 0.36184. That will be 0.49374, but to 3 significant figures, I'm going to write 0.494. 0.494 to 3 significant figures. That is that. So this has been it for this second part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next videos.